Okay, so good day, everyone. In this video, we are going to continue with some more examples. We will try to determine if some conditional statements are logically equivalent using the laws that we have discussed. Okay, now let's proceed to the first one. So P implies Q and P implies R. Is it logically equivalent with P implies Q and R? Okay, so let us see. So the first thing that we can do is to convert this conditional statements or implications into the form of not P or Q. Okay, so P implies Q, that is equivalent to not P or Q. And the P implies R is equivalent to not P or R. Now, we see a similar variable in both sides, so we can factor that out. So we have the not P, or the AND of Q and R. Okay, Q and R. Now, we can now convert this form into the implication of form. Okay, so we have P implies Q and R. So you can treat Q be equal to Q and R. Okay, now for the second example, we have P implies Q or P implies R is logically equivalent with P implies Q or R. So let us see. So we will convert this into implication forms. So we have not P or Q or not P or R. Now, similar to the other side, we are going to factor out not P or, okay, using the distributive law. So we have not P or the Q and R. Q or R. Okay, so we can now express it as P implies Q or R. Okay, so we can assume that Q is equal to Q or R. Okay, so which gives us the P implies Q form. Now, let us move on to some more examples. So let us try to prove this statement. So P implies R and Q implies R is logically equivalent to P or R implies R. So let us see. So let us convert this into implication forms. So we have P implies Q. It's logically equivalent to not P or Q. Okay. So we have not P or R and not Q or R. Okay. So what can we do next? So we have here the similar statement or R. So we can factor that out. So we have not P and not Q or R. Okay, so we don't have to exchange their positions. Okay, so we just factored out the not R. Now, what we can do is to use De Morgan's on this. So factoring out the negation, so this will give us P and this will become OR and then Q or R. Okay, and now we can treat this like the P in a variable, P equals P or Q. So we have the not P or R in a form, which gives us P or Q implies R, which is the same with this one. Okay, now let's move on to the next example. We have the P implies R or Q implies R. It's logically equivalent to P and Q implies R. So we have we will convert this into implication forms, not P or R, or not Q or R. Okay, so similarly, we see a pattern here. We have the not or R. So we can factor that out. So we have the not P or, the not P or not Q or R. Okay, so we factored out the not R. Okay, now we can use De Morgan's again. We will factor out the negation na operator from this. So we have the not of P and Q. So using the De Morgan's, this or became and. Okay, so P, and now we can express it into this form. Okay, P and Q implies R. So we can let P be equal to P and Q. Okay, so in short, we can convert this into not P or R, so which gives us this form. Okay, and we have now proven all of these conditional statements.